For this video, we are going to talk about piecewise functions. We're going to graph them as well as analyze them and talk a little bit about function notation. For this first example here, we're going to sketch the graph of the piecewise function, identify the domain, range, and any discontinuities. And then we're actually going to do this first, determine the values for this function notation down here. So I just want to take a quick second to talk about what piecewise functions are. So remember, piecewise functions are just pieces of functions put together, okay, with restricted domains. So in this case, we're going to be graphing the x squared function when the x values are less than 0. And we are going to be graphing the square root function when x's are greater than or equal to 0. One thing, let's get the graph ready here quick before we start plugging into this function notation. But one thing I like people to do when they're graphing piecewise functions is to notice what I call the boundary number. Okay, so the boundary number is this domain where it kind of switches for the different chunks of your graph. So in this case, x equals 0. Maybe I won't do orange. Let's do green because I feel like that'll stick out better. But so this boundary line right here is x equals 0 is going to be the part that switches over the function. So I like to just draw a dotted line here because both sides of your function, both pieces of your function have to line up and have to hit that boundary line. Okay, so they have to be touching that boundary line. Now, in order for it to be a function, you have to have an open circle and a closed circle. You could have two open circles, you just can't have two closed circles. So I like to graph that boundary line just to keep track that the sides need to touch it. Let's go ahead and look at this function notation quick here, plug in a couple of values before we actually get started because we're going to make some tables to graph these functions and then plot the points so we can see what it looks like. So let's go ahead and look here. So this is f of x. So this gives us our x value in here that we're going to plug in. So these are the domain values. Because we have chunks, you have to see where does -2 fit? What domain is that in? So is -2 less than 0 or greater than or equal to 0? Well, it's less than 0, so we're going to actually plug it into that x squared function. So you're just going to plug -2 into x squared. -2 squared is 4. So the ordered pair that goes along with this that we'll actually plot, remember this was the x value, and then this is our output or our y value. So the ordered pair that this connects to is -2, 4. So on the graph, we could go to -2, 1, 2, 3, 4, and put a dot. So that's going to be a point on our graph. Next one is f of 0. So we're going to figure out where 0 needs to go to. So what part of the function of this piecewise function does 0 fit into? So is 0 less than 0 or greater than or equal to 0? So it is greater than or equal to 0. So this is going to go into the blue function or the square root function. So we'll take and do the square root of our input, which is 0. Square root of 0 is 0. So the ordered pair that goes along with that is 0, 0. Then we can plot that. So that is part of our function. And then the final one is f of 3. 3 is bigger than 0, so it is going to go into the blue function as well. So we will do square root of 3, which you can type into your calculator to get a decimal for that so that you know about where you're going to go to. So 3 was the input. Square root 3 is 1.73. And then you can plot that. So 1, 2, 3, 1.7, so not quite to 2, and get that. So that's just 3 examples of points. So let's take a look and actually go and make tables for this and plot the rest of the values. So I'm just going to make a table over here. All right, so let's go ahead and make a table of values for this first function. Now, here's the important part. You need to plug the boundary line into all of your tables, okay? So into every function, you need to make sure that you go all the way to the boundary, even if the boundary isn't part of the function. Okay, if it's not part of the function, we will handle that with an open or a closed circle. So if we're going to graph this function here, so we're going to plug in our x's and we're going to get x squared for that f of x. We need to plug in 0. So I'm going to start with 0 here. And then we want x's that are less than 0. So 0, -1, -2, -3. If you need more, you can. Now we just plug those in. So we're just going to square them. So 0 squared is 0. -1 squared is 1. -2 squared is 4. And -3 squared is 9. So then you want to decide for this boundary value, okay? So remember that was the boundary value that was on this, the end of that domain. So this says x is less than 0. So this, when we plot it, is going to have an open circle because it's less than 0, not equal to 0. So when we plot these values, we will put an open circle there. The rest of them, closed circles, they're all part of the graph. So let's go ahead and graph those. So at 0, 0, okay, we have an open circle. -1, 1. -2, 4, we already have plotted. -3, 9. And then you can connect those. We'll see how well I can do. Not great. Okay, so connect those. Then we can do the other part of the function. Okay, so again, create a table. The few values, however many you think you need to fill up the whole graph. And this time we are going to be doing the square root function. And this time we want x's that are bigger than or equal to 0. So again, we'll plug in the boundary limit. And then we want numbers that are bigger than 0 as well. Okay, now you're making the table. So I would pick nice values here because not all numbers are nice to square root, as we saw with this 3. So I would choose numbers that you can square root easily, like 1, like 4, 9. Those are going to be really easy to do the square root of. So square root of 0, 0. Square root of 1, 1. Square root of 4, 2. Square root of 9, 3. Then you can go ahead and plot those. First, you want to analyze if the boundary limit here, or the boundary value here, is an open or a closed circle. So this time we had x's that are greater than or equal to 0. So this is going to be a closed circle on 0, 0. So when we go to plot that, we'll have a closed circle, which we already plotted from our function notation. So it just covers up that open circle. That means this function is going to be continuous. There isn't going to be a break because they overlap each other. So 0, 0, 1, 1, 4, 2, 9, 3. And then you can graph that. And then we have our piecewise function done. So when we go to analyze this, analyze the domain, you've got an arrow to the left, you've got an arrow to the right, and we don't have any breaks in here since these two circles overlapped. So the domain is going to be -infinity to infinity, or all real numbers. The range, we have a lower number here, we have a minimum here, so a low y value, and then they go up. So we have a range of 0 to infinity. And then this function is continuous. It doesn't have any discontinuity, so no breaks. All right, let's take a look at this one that has 3 pieces to it. So now in this one, we're going to have 2 different boundary lines. So we've got this boundary line of x equals -3. So we'll go ahead and plot that. So at -3, I'm just going to do a dot. Now, this isn't part of the graph. That's why I do a dotted line. It's not actually part of the graph. It's just to help me recognize that the 2 pieces need to butt up to that line so there aren't any gaps. Then we've got another one at 0. So I'll do x equals 0 as well. So we're kind of going to have three different parts to this graph. Okay, so we've got this very left one, this center one, and the one to the right. So let's see, we can do different colors here. So we'll do this one as the red part, this one as the blue part, and we'll do purple for this bottom one. So then let's take a look and actually plug in some points first here. So we've got f of -2. So we want to take and plug -2 in where it goes. So is -2 less than or equal to 3, between -3 and 0, or greater than 0? So -2 is between 0 and 3. So we'll plug this into the blue function. And when we plug it in, we just get 2. There isn't an x value here. So every number you plug in between -3 and 0 is going to kick back 2. 0, so f of 0, 0 is equal to 0. So it is also going to be in this blue function. So 2 again. Ordered pairs here would be, remember this x is, your input is -2, your output is 2. Input is 0, output is 2. And then 3 is greater than 0, so 3 is going to go into this purple function. So we will do 3 cubed, which is 27. So if we plug in 3, we will get back 27. So we can plot these 2 points. This one's going to be off of our graph, but we can go to -2, 2. So -2, 2. And we can go to 0, 2 and plot both of those before we get started here. All right, then let's create a table for each of these. So let's create a table for this first one. And so again, when you're doing this, you want to make sure that you plug in the boundary line. Okay, so in this case, we want to plug in -3 because that's our boundary domain value. And then you want to plug in numbers that fit this domain. So x's that are less than or equal to -3. So we're going to want to go lower than -3, -4, -5, -6. Okay, then start plugging them into the absolute value. Remember, absolute value is the distance from 0. So -3 is 3 units from 0. Absolute value of -4 is 4. -5 is 5. -6 is 6. Then we can decide if this is an open or a closed circle on this boundary number. So decide if 3 is part of the domain or not. Okay, and this says less than or equal to -3, so this is going to be a closed circle. So when we plot this point, -3, 3, it's going to be closed. So -3, 1, 2, 3, closed circle here. Plot the rest of them, -4, 4, -5, 5, -6, 6. And from your work with apparent functions, you know this will just keep going. And then you can connect that. Okay. Then we can go ahead and do the middle chunk. Okay, so then this middle chunk is just 2. So every time you plug in an x, you're going to get a 2 back. Remember to plug in your boundaries. Now this one has 2 boundaries. So plug in every integer from -3 to 0. Okay, every number from -3 to 0. So -3, -2, -1, 0. Okay, so plug in all of those. And when you plug in -3, you get back 2. When you plug in -2, you get back 2. -1, you get back 2. 0, you get back 2. Okay, it always gives you back 2. Decide on your boundaries whether they're open or closed. So this one says x's that are greater than -3, so not equal to, so this is going to be an open circle. 0, x's that are less than or equal to 0, so it's equal to this one, so closed circle. So when you plot -3, 2, it's going to be an open circle. -2, 2, -1, 1, 0, or sorry, -1, 2, 0, 0. Connect those. Okay, but notice there is a red dot and a blue open circle on that green line. Okay, both parts of the graph need to butt up to that boundary line. Then the final chunk here for the x cubed portion. So we have x, and then we have x cubed, and this is for x's that are bigger than 0, but plug in 0. 1, 2, 3. 0 cubed is 0, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, like we found out earlier. Decide on your boundary limits here, okay? So 0 is not part of this, okay? It's x is greater than 0, so this is going to be an open circle when we plot that, but you still need to plot it, okay? So 0, 0 is going to have an open circle. 1, 1, 2, 8. Everything else is closed. It's only the boundary point that's either open or closed, okay? Then you can connect it. And then we have our piecewise graph. So now let's analyze it for domain, range, and continuity. So domain has an arrow to the left, an arrow to the right, and an open closed circle on top of each other. So this -3 is part of our domain, so is the 0. So all domain values are covered. Range has this low point here at 0, 0, and then it goes up. So this graph actually covers the whole range. It just duplicates these. Okay, the 0 is not part of the range because it's an open circle. So this one is 0 to infinity. And then there is jump discontinuity in 2 different places. Okay, at x equals -3, there's jump discontinuity, and at x equals 0. So things you're looking for, that the red and the blue butt up to this green, and the blue and the purple butt up to this green. Okay, there's a closed and an open circle, closed and an open circle. Okay, and then you've graphed everything between. So then let's take a look at writing the function, writing a piecewise function. So we'll say f of x equals, then count how many pieces there are. So there's 3 pieces here. Okay, so you're going to need to have 3 chunks. You're going to have 3 equations, and then you're going to have to write out 3 different domains. So this equation, if whatever the domains are here. So then let's go ahead and look at the boundary limits to help us with the domains. So this boundary line right here is at x equals -2, and then we've got this boundary line here at x equals 2. So x equals 2 for this one. Let me put a different color over here. X equals 2. That one should say -2. Okay, so now when we're going to go and analyze these portions of the function, okay, so we've got this one with an open circle and to the left. Okay, so this is x's that are less than -2. So this one is x's that are less than -2. Remember, not equal to, because it's an open circle. This middle chunk has a closed circle on 2, -2, a closed circle on -2, and an open circle on +2. Okay, so we're going to be between -2 and 2. So you have -2 is less than x is less than 2, with a closed circle on the -2. So an equal sign with the -2. And then this part of the graph is closed on 2 and then keeps going as x gets bigger. So this one is going to be x's that are greater than or equal to 2, closed circle on the 2, and everything bigger than that. So now we just have to figure out writing these equations. They're all linear functions, okay? They're all straight lines, so they're all going to follow mx plus b, okay? Slope and y-intercept. So we need to analyze the slope of each one and what the y-intercept would be if it actually touched the y-axis, if it's not. So let's take a look at this red part. Okay, you see it goes through this point and this point, so it has a slope of down 2 over 1. So this one has a slope of -2. And if we continued that, okay, so if we continued going down 2 over 1, down 2 over 1, it would hit the y-axis at -1. So it would have a y-intercept of -1. So this function would be -2x minus 1. The blue function, okay, so we need to look at the slope. So let me erase this part. Okay, so let's take a look at the slope here. So we see it going through a point here and here. So this is up 1 over 1, up 1 over 1. So this has a slope of 1. Hits the y-axis at the origin, so the b value is 0. So this one is just x, 1x plus 0, so just x. And remember, you don't need to write the y because that's right here with the f of x. So this says f of x equals x, or f of x equals -x minus 1. Then the last chunk of the graph, so again, take a look for slope. So we see it going through this point and this point and this point. So this is up 2 over 1, up 2 over 1. So this has a slope of 2. And then continue that backwards, okay? So if we were to continue that slope, 2 and 1, you would end up at this y value, okay, on the y-axis of -3. So the y-intercept is -3. So this chunk of the graph is 2x minus 3. And that's how you write your piecewise function. So you just got to make sure that you use those boundaries. Okay, remember those boundaries of -2 and 2 should be in your domains, deciding on the open and closed circle and then what the parent function is, in this case linear, so checking out the slope and the y-intercept.